Hey guys, Mr. Mackey here, and welcome to the final part of our surds for this week. Now, I was showing you how to rationalise the denominator, which is when we change an irrational number, which is a surd, into a rational number. And I set you the challenge to rationalise the denominator of this problem. So, let's get on with it. So what we do is we multiply the numerator and the denominator by the opposite of our denominator. So instead of 4 minus root 6, it becomes 4 plus root 6. Now, when we do this, our denominator, 4 times 4 becomes 16. 6 times 4 becomes plus 4 root 6. Negative root 6 times 4 becomes negative 4 root 6. And our denominator becomes negative 6. These two cancel each other out because plus and minus becomes 0. So it becomes 16 take away 6, which becomes 10. So I'm going to write that down here, 10. Meanwhile, our numerator, it becomes 2 multiplied by 4, which is 8, and 2 multiplied by root 6, which becomes 2 root 6. Now, I'll give you a mark if you correctly rationalise with that. I'll give you a mark if you correctly got the denominator, and I'll give you a mark if you correctly got the numerator. But I'm not going to give you full marks if you stopped there. There's one more thing you need to do. Simplify. Because all of these are even numbers, so we need to cancel it down. So, 8 and 10, they're both in the 2 times table. This becomes 4. 2 and 10 are also in the 2 times table, so it becomes 4 plus root 6 all over 5. And that is fully cancelled down, and we have completely rationalised the denominator because we've turned the surd into a rational number, which is 5. So, we're going to go to the final part of rationalising the denominator today, and it's probably going to be the hardest one yet. How hard? Let's get into it. Now, this time we have a surd problem on both the denominator and the numerator, but we still rationalise the exact same way, it just requires a bit more work. So, let's check it out. So we have 3 plus root 2 over 3 minus root 2. So what do we do first? We rationalise the denominator. So we multiply both the numerator and the denominator by 3 plus root 2, because it's the opposite of what the denominator is. So let's do the denominator first, because that'll probably be the easiest bit. 3 times 3 becomes 9. Negative root 2 times 3 becomes negative 3 root 2. 3 times root 2 becomes positive 3 root 2. And negative root 2 times root 2 becomes negative 2. Tied that all up, the denominator becomes 7. How I know this? Because the 3 root 2's cancel each other out, and 9 take away 2 becomes 7. So, now let's focus on the numerator, the hard bit. Sorry. So, let's firstly do our 3 times 3, which gets us 9. Then we do our 3 multiplied by our root 2 right at the back, which becomes plus 3 root 2. Then we do this side, so root 2 multiplied by 3 also becomes 3 root 2. And then our root 2 multiplied by our root 2's become 2. So let's tie this up a bit. 9 plus 2 becomes 11. 3 root 2 plus 3 root 2 becomes 6 root 2. That's our numerator complete. Do we simplify? No, because they don't go into each other. Well, 7's a prime number, that should kind of give you a hint. And we leave it like that. So, when we rationalise the denominator, we end up with 11 plus 6 root 2 all over 7. So we'd use a similar method, we just have to do a bit more expanding at the numerator, because we have 2 problems to work out. Let's look at another one. So what about this problem? Well, firstly, we need to What about this problem? Well, let's start rationalising the denominator first. So we have 3 plus root 3, so when we rationalise it becomes 3 minus root 3 on both. And now we can start expanding. So let's do the denominator first, because we always start at the bottom. 3 times 3 becomes 9. 3 times root 3 becomes 3 root 3. 3 times negative root 3 becomes negative root 3. Well, negative 3 root 3, sorry. And then root 3 times negative root 3 becomes negative 3. When we tie this all up, they cancel each other out. And the 9 take away 3 becomes 6. So that's the denominator done. We might need to simplify it. Don't know yet. So let's focus on the numerator. So 5 plus root 12 multiplied by 3 take away root 3. So let's start expanding. Let's do 5 multiplied by 3. That becomes 15. Root 12 multiplied by 3. Now, the problem is root 12 can be simplified. How can we simplify it? Well, we find a pair of factors, and one of them is a square number. So let's look. Well, we have 1 and 12. One's a square number, but that won't really get us anywhere. What about 2 and 6? Well, neither of them are square numbers. 3 and 4? Now, that is a square number. So what we're going to do is we're going to rewrite that root 12 into its simplified form because it might make it a bit easier. So when we do it, it becomes root 4 multiplied by root 3. Root 4 can be simplified to 2. So this becomes 2 root 3. Now let's carry on. So we did 5 times 3 to get 15. 2 root 3 multiplied by 3, that becomes 6 root 3. Now let's do the other side. So we now do 5 multiplied by negative root 3, that becomes negative 5 root 3. I'll just do a nice long arrow. And then 2 root 3 multiplied by negative root 3, that becomes, well, the root 3's become, well, just 3. So it's basically 2 times 3, so it becomes negative 6. So now we can simplify it. 15 take away 6 becomes 9. 6 root 3 plus 5 root 3, minus 5 root 3, sorry, becomes root 3. So it's 9 plus root 3 over 6. Now we could simplify it so it becomes 3 over 2 plus root 3 over 6, but I tend to leave them as just one fraction. It's easier, it's neater, it saves space, and it gives you the answer, so just to keep it like that. Now, rationalise the denominator is fairly simple as long as you remember how to expand the brackets. That you have to change the plus and the minus to the opposite when you do it. So I think it's time for our challenge for today. So here is your challenge for today. Obviously, because it's a Sunday, I'm going to go through it in about 5 seconds, but rationalise the denominator of this problem. Pause the video so you can have some time to work on it on your own, and I'm going to go over it in 4, 3, 2, 1, now. So, the first thing I'm going to do in this problem is I'm going to simplify the surds, because it's easier and it's neater. So let's do the denominator part first, because that's what we're going to be rationalising here. Root 8, let's think of some square numbers. Well, we could do 1 and 8, but that won't be useful. 2 and 4, that would be useful, because 4 is a square number. So that will give us 2 root 2. Now what about root 32? Let's think of some square numbers. So we could do 4 and 8, because 4 is a square number, but then we can just simplify the 8 again, and it's a couple of steps behind. Let's see if we can think of any more. What about 16 and 2? That works. 16 and 2 we don't simplify. So we simplify that to 4 root 2. Now that we've done that, let's rationalise the denominator. So we multiply both sides by 6 minus root 2 and 6 minus root 2. And let's do our denominator first, because we always have. 6 times 6 becomes 36. Root 2, 2 root 2 times 6 becomes 12 root 2. 6 times negative 2 root 2 becomes negative 12 root 2. And 2 root 2 times negative 2 root 2 becomes negative 8. Because that's what we started with, remember? Negative 8. So, let's tidy this up a bit. The 12 root 2's cancel each other out. So it becomes 36, take away 8, and that becomes, which I'll write over here, 26. Our denominator's done. So now let's focus on our numerators. So first we do 7 multiplied by 6, which gets us 42. Then we do 7 multiplied by negative root 2. This becomes negative 7 root 2. Now we do 4 root 2 multiplied by 6. This becomes positive 24 root 2. And then we do 4 root 2 multiplied by negative root 2. That becomes negative 8. No, it doesn't. it becomes, yeah, it does. I'm just teasing. It becomes -8. The reason why? Because the two root 2's multiply together to become 2, and we multiply that by 4, it becomes 8. I was tricking you there. So now let's tidy this one up a bit. 42 take away 8 becomes 34. 24 root 2 take away 7 root 2 becomes 17 root 2. Now again, you could simplify it by doing 34 over 26, so it becomes 17 over 13, but at the end of the day, you can't simplify the surd part, so there's not really much point. I'd leave it as just that, but if you did write it as 17 over 13 plus 17 root 2 over 26, that's absolutely fine. So, now we're done with surds, and also, this means that we only have a week left of my channel. Because, obviously, schools are shutting for the summer on the 17th of July, on the 19th of July, which is the Sunday following that, will be the final day of my channel. So, what I'll be doing is I'll be doing a whole bunch of activities during the week, just to keep everyone excited and stuff. But I hope you have enjoyed this channel, hope it's been helpful. Look, it's going to be sad that this is going to end, but schools are going to be reopening and you'll be meeting your teachers again and they'll be helping you with the work, so you don't really need me anymore. So, bring on next week for the final week of Mr. Mackey's Maths, and keep on with those surds, guys. Take care, and I'll see you tomorrow.